Hi everyone, super excited to be here today. And I'd like to talk about container orchestration for AI. My name is Andrey, I'm the founder of dstack. And what we do is we build an open source alternative to Kubernetes and Slurm, specifically for AI workloads. Perfect. So you can think of dstack as a container orchestrator, and in that case, it's very similar to Kubernetes. Just like Kubernetes, it orchestrates containers over any cloud provider or any on-prem. And containers means that you can use any Docker images whatsoever, but the orchestrator takes care of, well, basically orchestration, the workloads for you. And the thing is that if we look at what orchestration tools are available in the market, they're not so many really. And that's why if you go, for example, to any cloud provider or even data center, what they really offer is like either Kubernetes or Slurm. And Kubernetes is a kind of a vanilla one. You can do pretty much anything you want, but it's a low-level interface, means that Kubernetes is designed for DevOps and platform teams, but not for AI teams. And as much as we like Kubernetes, there are many DevOps people that really like Kubernetes, but through my experience, I never seen any AI engineer who really said, I really love Kubernetes. And that's for a reason, because Kubernetes offers a low-level interface. And when it comes to AI development, you want to focus on AI models, on training, and with Kubernetes, you have to build basically your platform on top of that. That's the biggest deal. And instead of focusing on models and data as a company, as a team, you actually spend a lot of time actually figuring out the infrastructure, the orchestration. And instead of basically doing AI, you build internal platforms instead. Right. So here's a diagram how dstack works. So on the bottom level, we have accelerators, actually hardware. And dstack is an open platform, means that it can work with any accelerator. It means NVIDIA, AMD, dstack also supports Google TPU, for example, and then also Intel Gaudi, and it is extensible for, like, to support any accelerator. On the level above, we have on one hand side, we have cloud providers, and dstack natively integrates with any cloud providers, which includes hyperscalers and also neoclouds. And native integration means that it would allow you to provision and manage infrastructure with your cloud provider as you want. And on the right-hand side, we have on-prem. dstack supports both like cloud and on-prem, but I'll show you in a minute how this works. Great thing is that TensorWave is one of their cloud providers that is supported with dstack, and I'll mention in the slide how you can already use dstack with TensorWave. On top of that, we have dstack, and this is exactly what like you would use. It's an abstraction over the hardware and then cloud providers, and it offers you 5 interfaces. Dev environments for anything that is requiring an ID or notebooks, tasks for anything training, fine-tuning, or batch jobs, services for inference, fleets for managing clusters, and volumes for persistent storage. And if you look at this, dstack basically is an abstraction. It's a simplified interface over any infrastructure designed tailored basically for AI teams. And because it's a container orchestration, you are free to use any frameworks, work with any data and any models. Right. The value dstack brings here is that it simplifies a lot the container orchestration. On one hand, just like Slurm, it is built for AI teams. However, it's not only training, it covers anything from development from inference. On the other hand, it's a lot more simple than Kubernetes. And with one of the central idea with dstack is that it's vendor agnostic. Vendor agnostic in all of those senses. On one hand, it works with any cloud provider. On the other hand, it supports any hardware. And more than anything else, it allows you to use any inference or training frameworks as you want without making you use any magic. Basically, you have 100% control over what you run. Here's just a quick example of a dev environment. It's most simple thing that you can use with dstack. Imagine you want to just use your own desktop IDE to work with a remote environment. And this is how you define it. You can basically specify your Docker image or version of Python. You specify what resources you need. and then you do dstack apply. Dstack would automatically provision the compute, so whether it's going to be cloud or any on-prem cluster, and you would basically access this using your desktop ID. But this is just a simple example. Here's a bit more complex thing. Task. Imagine now you want to run large training, and here's how you define a task. You specify the number of nodes, like basically the size of the cluster which you want to use. Then you specify the commands you want to run. And here again, this is the part which I really like, that you are free to use any distributed framework of your choice, like whether you're using Megatron, Tortron, Accelerator, whatever. dstack would pass these environment variables, which allow you to basically pass all the required information to the distributed framework to make it work. And then if you run dstack apply, dstack would automatically provision the master node and all the worker nodes and make sure that this is running on the cluster which has high internode connectivity. Services. I think something happened to the slide. It says the markup a bit broken, but basically this is a way how you can define a service. So you define which model you want to run, how you want to run it, like whether you want to use VLLM or SGLang or any other, and then also specify their auto-scaling rules, and then you do dstack apply, and dstack would basically turn this into a scalable, secure endpoint, which you can basically run on any cloud or on-prem cluster here. Here's an example of how you can provision clusters. You can just specify the requirements for the cluster, and then again invoke dstack apply, and dstack would automatically provision that cluster for you within the cloud provider of your choice. Here's how you use on-prem clusters. Imagine you have, let's say, a rack or multiple racks with GPUs, and in order to use them with dstack, you just need to list the host names of these machines and provide the SSH credentials. Well, there are many other things you can specify. Also, blocks is something that you can specify into how many slices you might want to, well, basically split every machine, so you can run concurrent workloads there. And then if you do dstack apply, you would be able to use this as a fleet for any other workloads like dev environments, tasks, and services. Well, the title is SSH fleets, but it should be volumes. Volumes is a way to use persistent storage. Like cloud providers and even on-prem, they support like network volumes, which allows you to persist data across runs. And so this is pretty useful whether you are doing development or running training or even inference for storing cache of the models, so like checkpoints and everything. And dstack offers that these volumes as an abstraction as well. And with that, I invite everyone to take a look at dstack's GitHub repo. dstack is 100% open source, and yeah, share your feedback with us. Thank you.